Today's lecture focuses on resilience thinking as a framework for understanding, designing, and governing urban systems under conditions of uncertainty, disturbance, and long-term change. Contemporary cities are increasingly exposed to climate change, economic shocks, social inequality, and environmental degradation. Traditional planning approaches, often based on optimization, prediction, and control, have proven insufficient in addressing these complex challenges. Resilience thinking offers an alternative perspective. Rather than treating cities as stable, engineered objects, it understands them as dynamic, complex socio-ecological systems that must continuously adapt, reorganize, and sometimes transform in response to shocks and stresses. In this lecture, I will first introduce the core principles of resilient cities. I will then explain how resilience thinking reframes urban systems, before discussing resilient systems and the 3 rupees framework. Finally, I will illustrate these ideas through the Christchurch case study, which demonstrates how disruption can become an opportunity for learning and transformation. Resilient cities are characterized by diversity and redundancy. This means designing urban environments with multiple functions, mixed land uses, and overlapping systems. When one element fails, others can compensate, allowing the city to continue functioning. Flexibility and adaptability are equally important. Urban spaces should not be fixed to a single function or use. Instead, they should be capable of change over time, through reuse, seasonal adaptation, or temporary transformation. This allows cities to respond to uncertainty rather than attempting to resist it. A central principle is safe-to-fail design. Resilience thinking accepts that disturbances will occur and focuses on managing failure in controlled, non-catastrophic ways. Examples include floodable parks or adaptable public spaces that absorb shocks rather than collapse under them. Nature-based solutions play a critical role in resilient cities. Landscapes and ecological systems are treated as infrastructure that can address water management, heat reduction, biodiversity loss, and social well-being simultaneously. Connectivity, both ecological and social, strengthens networks within the city, while equity and inclusion ensure that resilience benefits all urban residents. Resilience thinking begins with the recognition that cities are complex adaptive systems. They are composed of interconnected social, ecological, and technical components that interact across multiple scales. These systems are non-linear and unpredictable. Small changes can produce large effects, and cause-effect relationships are often difficult to trace. As a result, resilience thinking does not aim to eliminate uncertainty but to design with it. This perspective challenges traditional planning approaches that assume stability and control. Instead, it encourages planners and designers to work with interdependence, feedback, and emergence as fundamental characteristics of urban systems. Another key shift introduced by resilience thinking is the move from objects to flows. Urban systems function through the continuous movement of energy, water, materials, people, and information. Resilience is not achieved by optimizing individual objects, such as buildings or infrastructure, but by maintaining the functioning of these flows under stress. For example, energy resilience depends not only on power plants but on distribution networks, demand patterns, and social practices. By focusing on flows, resilience thinking highlights vulnerabilities that are often invisible in object-based planning, such as dependencies, bottlenecks, and cascading failures. Conventional urban systems are often designed for peak efficiency under normal conditions. However, highly optimized systems tend to be brittle and vulnerable to disruption. Resilience thinking prioritizes adaptability over optimization. This means accepting some inefficiency in exchange for flexibility, redundancy, and the capacity to adjust over time. Flexible zoning, adaptable public spaces, and modular infrastructure are examples of how adaptability can be embedded spatially. Rather than locking cities into fixed configurations, these approaches allow systems to evolve in response to changing conditions. Redundancy and diversity are central to resilient urban systems. Multiple systems performing similar functions, such as decentralized energy or water systems, reduce the risk of systemic failure. Safe-to-fail design extends this logic by acknowledging that failure will occur. Instead of preventing failure entirely, resilient systems are designed so that failure is manageable and does not cascade into catastrophe. This approach represents a fundamental shift from risk avoidance to risk management, and from control to learning. Resilience is not an outcome but a capacity, the ability of a system to adapt, respond, and continue functioning under shocks and long-term stresses. It is dynamic, context-dependent, and shaped by social, ecological, economic, and political factors. The 3 rupees framework helps structure resilience strategies. Robustness, which focuses on resisting shocks; recovery, which emphasizes bouncing back; reorientation, which involves transforming toward more sustainable configurations. While robustness and recovery are important, long-term urban resilience requires reorientation, using disturbance as an opportunity for systemic change. Resilient cities function as learning systems. Monitoring, feedback, and adaptation are essential components of resilience thinking. Temporary projects, pilot interventions, and experimental designs allow cities to test ideas, learn from failure, and adjust strategies over time. This requires institutional flexibility and governance structures that support experimentation rather than rigid control. Learning transforms resilience from a technical challenge into an ongoing social and political process. The Christchurch earthquakes caused widespread destruction, creating large areas of vacant and disrupted urban space. Rather than treating this solely as a problem, the city became a laboratory for resilience thinking. Temporary and community-led interventions such as gap filler, greening the rubble, and Festa transformed vacant sites into social, cultural, and ecological spaces. These projects were low-cost, reversible, and experimental, embodying safe-to-fail principles. Local food systems, including urban farms and farmers' markets, strengthened short supply chains and social networks, enhancing food system resilience. Importantly, these initiatives supported not only recovery but learning and reorientation. Christchurch demonstrates that resilience emerges through flexibility, participation, multifunctionality, and continuous adaptation. To conclude, resilience thinking reframes urban systems from static, efficiency-driven structures into adaptive, interconnected socio-ecological systems. It emphasizes diversity, redundancy, learning, and transformation rather than control and optimization. The Christchurch case illustrates how shocks can become catalysts for innovation and systemic change when cities embrace flexibility, participation, and experimentation. Ultimately, resilience thinking positions urban design and planning as ongoing, adaptive, and participatory processes, enabling cities not only to withstand disturbance, but to evolve toward more inclusive, sustainable, and resilient futures.